Hey third grade, this is Mrs. Todd, and we are going to review a concept that we talked a little bit about yesterday in class, but we are going to spend a little bit more time on it today because it's one of those things that we're going to have to learn, especially to go on to 4th and 5th grade. It's one of those concepts that we kind of use a lot. So we are going to be talking today about the property of multiplication called the distributive property. Big word. Go ahead and say distributive property. It means something that multiplication equations are able to have done to them, something that stands true every single time. So before I start teaching, here are some things that you are going to need. So you're going to pause the video as soon as I tell you what you're going to need. You are probably going to need a piece of paper and a pencil, something to write with. Okay. You may also want something to make arrays with. So maybe you want to use some Legos, or maybe you want to use some cereal, or maybe you want to use some pennies, or you have some buttons that you can use. Something to build the arrays if you'd rather do it that way. Or you can just do like I am going to do and use paper. I'm going to use paper on my iPad, but you can use paper for real to be able to draw with your paper and your pencil. So go ahead and pause my video. Go grab either a paper and pencil or some Legos, cereal, pennies, buttons, whatever you want to build the arrays with. You'll still need a paper and a pencil. And then come back and restart the video. Okay, so I am going to... Let's move down to a new piece of paper. We are going to talk about building a big array right now, and then the distributive property, we're going to break it up into some smaller arrays. So right now what I want you to draw is what would look like, what would be the array for 7 times 3. And remember, that would mean 7 rows of 3. So you're going to build that either with the actual items that you have in front of you or just draw it on paper. It's up to you. So I'm going to make my 7 rows of 3. 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows, 7 rows of 3 that I have right now. And over here on this side, I'm going to change my pen color so it stays separate from the rest of it. I'm going to draw a bracket around this big whole array. And I'm going to label what that picture shows me. And that picture shows me 7 times 3. And if I count up all of my circles or objects, whatever you used, I have 21 of them. Distributive property means that we're going to break this up into 2 smaller arrays. When we start multiplying by big numbers, it sometimes is easier to think about it as 2 smaller multiplication problems. It makes it easier to figure out the answer, and we don't have to go back all the time and count all the pieces. So if I think in my head, and this is my thinking bubble in my head, about the number 7, I'm going to break that 7 into 2 smaller numbers, and I'm going to break that 7 into a 5 because those are easy to multiply by, and a 2 because 2s are easy to multiply by. So I'm thinking of that 7 and breaking it into a 5 and a 2. So now I'm going to use my magic pencil. You might have a you might want the pencil for this, or you could use something like a ruler or a straw to draw your line if you're using actual pieces of something and not just drawing on paper. But we're going to break this up into 2 smaller multiplication problems. Okay? I want you to count down 5 rows of 3. 1, 2, 3, 4, 5. And I want you to cut this array in half right there, either with a pencil, if you're just using paper, or maybe you want to use a straw or a stick and put your arrays separate. Okay, so this is now a smaller array. I have 5 rows of 3 up here now. And if I write 5 rows of 3 in a multiplication, it's 5 times 3. I can skip count by 3s, or I can think of the commutative property where I can turn those around and I can skip count by 5s to figure out how many I have here. So 5 rows of 3 or 3 rows of 5 would be 5, 10, 15. I have 15 all together right there. Okay. Oops, didn't mean to do that. Let's put my dots back. Thought that would just erase my pencil. Okay. So now at this bottom array, I don't have 5 rows of 3 anymore. Now I have 2 rows of 3, which is 2 times 3, which means altogether I have 6 circles. So let's take a look at what we did in math terms. Okay, how this would look. I originally, in my big multiplication array, I had 7 times 3. That was the whole thing when I had it together. I broke that up into 2 smaller arrays. I have my top array, which is 5 times 3. I'm going to put that in parentheses because those were a group. And then I'm going to add to that, my smaller array at the bottom, which is 2 times 3. So if I think about that, I started with my big giant array having 21 because I started with 21 circles. And then if I counted what I had with my blue top part of my array, I had 5 times 3, which is 15. Oops, I want to use blue for that. And then my bottom array is 2 times 3, which is 6. So I have 6 counters down there. Now think about that in your head. Does 15 plus 6 equal 21? 15, 16, 17, 18, 19, 20, 21. It sure does. This is just a different way to break up 7 times 3. So let's take a look at another one. Go ahead and get out a different piece of paper if you're using a piece of paper, or clear your workspace and of whatever array you built last time. And let's take a look at a different one. Okay. I'm going to start with the array for, let's think, 8 times 2. I'm not going to put an equals right there, although some of you probably already know 8 times 2. I'm going to leave it alone. I'm going to build 8 rows of 2. So pause my video and build 8 rows of 2. 2, 3, 4, 5, 6, 7, 8. Okay, 8 rows of 2. I am always going to try to break this bigger number into a 5 if I can get it, or a 2 if I can get it, because those are my easiest to think about multiplying together. So if you think about an 8 and breaking an 8 apart, I can break an 8 apart into 5 plus 3. So we're going to break this, think about yourself as a surgeon, we're going to break this big array of 8 rows of 2 into 5 rows of 2 and 3 rows of 2. 1, 2, 3, 4, 5. So we're going to draw a line right there. Draw your line right there, or work with your manipulatives to break it apart. So my big array was 8 times 2, but now I have 2 smaller arrays. In my top, I have 5 rows of 2, which I would write 5 times 2. In my bottom array, I don't have 5 times 2. I have 1, 2, 3. 3 rows of 2, so I have 3 times 2. So now let's figure out how many we have all together to get me my 8 times 2. I started with my big giant array, oops, I want to use black, which was 8 times 2. I broke it into 2 smaller arrays, which was 5 times 2 for my top, plus the bottom array is 3 times 2. How many do we have all together in this part of my array that was 5 times 2? how many green circles do I have, or how many do you have at the top part of your array if you built this with me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 times 2 is 10. I'm going to carry my 8 times 2 down here. It's just going to follow along right now. So my top array I have 10, and in my bottom array where I drew the 3 times 2, I have 1, 2, 3, 4, 5, 6. 3 times 2 is 6. Put my plus sign there. So 8 times 2 must be the same thing as 10 plus 6. So 8 times 2, oops, pencil, 8 times 2 equals 10 plus 6, which is 16. Okay, so they might not seem as complicated right now when we only are multiplying by 2's. That you're like, Mrs. Todd, that was easy for me to figure out 8 times 2 already in my head. Why are you making me build this giant array? But when we get into things like 7 times 8 or 9 times 6, it's going to be easier to break it into smaller arrays. So it's good for us to learn how to do it now so we can get some practice. Let me show you another one. Because on your paper today that you're going to try to do to see if we are understanding what we're doing, it breaks it up another way. Okay, so let's say I have 3 times 7. Okay, so in my head I know that that is 3 rows of 7. So pause your video, and I would like you to make 3 rows of 7. Okay, so I just made 3 rows of 7. So I'm going to label my big array down here. I'm going to draw a bracket. 3 rows of 7, which is 3 times 7. Okay, I'm thinking of this row of 7 that I can break up into 2 smaller pieces. And when I think of a 7, remember we're looking for 5's and 2's, I'm thinking of I can break that 7 into a 5 and a 2. So I'm going to count over 1, 2, 3, 4, 5, and I'm going to split my array right here this way. So I drew a vertical line this time instead of horizontal. Okay. So now think about what these smaller arrays are showing. I'm going to erase some of this so that it is not quite as messy. Put my 7 over here. In this part of the array now, I don't have 3 rows of 7. I have 3 rows of 5. Okay. On this side of my cut line, I don't have 3 rows of 7. I don't have 3 rows of 5. I have 3 rows of 2. So it's the same thing. We just flipped our paper or made vertically instead of horizontally. It doesn't really matter. It's where you can find those groups of 3's or 5's and 2's that make the most sense for where to make your cut. So let's write this down mathematically. My big array was 3 times 7, 3 rows of 7, which is what I have right here. Okay. And then I cut my array into 2 smaller arrays of 3 times 5. That's what I have here. And then 3 times 2, which is what I have here. My 3 didn't change because my rows didn't change. I still have 3 rows. I just have 3 rows of 5 now and 3 rows of 2. So if I go down and I think, okay, what is 3 times 5? 3, 6, 9, 12, 15. I could count that way. Or I could count 5 3 times. 5, 10, 15. And if I look up here, I have 15 circles on this side of my array. And I look at 3 times 2, so I think 3 2 times, or double it. So 3 2 times is the same thing as 6, or I can count by 2's. 3 times 2, 4, 6. And now I have to add Let me carry my 3 times 7. 3 times 7 is the same thing as 15 plus 6, which means that 3 times 7 is 15, 16, 17, 18, 19, 20, 21. And if you count all those circles up there, there's 21 circles. All right, so you try today, see what you can do on that distributive property paper that you have, and hopefully this little quick mini lesson